Hello and welcome to this webinar today where we're going to take a look at Unreal Engine for product development. Now, we're using the term product development here in a very generic sense, in the way that we're going to take a look at how Unreal Engine can be utilized for visualizing designs and being able to assess designs and be able to work with different types of data in a real-time context, and why Unreal Engine is excellent for this. So a couple of things that we want to accomplish today is this nice big overview of not just the how, but the why. Why Unreal Engine for visualizing data. And that's what we want to answer in this webinar here, is this overall power of Unreal Engine for visualization. Specifically, we're going to be taking a look at some very cool data from Modus, and I should give a thanks to those guys for allowing us to use this excellent motorcycle that they've provided for us here. And this is CAD data that's actually come over from SolidWorks, and then we've translated it through 3ds Max and then brought it right into Unreal Engine. So let's jump in and take a look at the power of Unreal Engine for CAD visualization. So one of the big benefits right off the bat with using Unreal Engine for CAD visualization, for working with CAD data, is this ability to interact with your data live in real time. So in this case here, we have our motorcycle, and we're able to look at this motorcycle with beautiful materials on it, nice lighting. We can see some great reflections happening, and we can see all of the different components. We can grab these components and interact with them live. We can even grab components of the engine, pieces of the engine block, or different pieces of this motorcycle, and be able to visualize them and tumble around and interact with them to see how they work, how they feel, how they fit, but also to maybe work with beautifying the image to really sell the overall design or the concept. And this is the great power of something like Unreal Engine here, with the amazing graphics capabilities here to visualize something, this high fidelity look of things. Also, rapid iterations here, the ability to change materials on the fly, changing paint jobs, taking a look at how the motorcycle would look with different paint liveries on them. As well, we can explore different lighting environments, how the design works in different lights, for example, under a different red kind of glow here, for that matter. And with that change of iterations, we can also look at design changes. How accessories might work with this motorcycle, for example. So here we have these saddlebags, and we can turn them on and off, which is an option, of course, with this motorcycle. You can have these on or off, but we can do more than that. We can see how they work with the motorbike, with the overall design, but we can also work with the materials on that. We can see how those materials might work with the overall design of the existing livery or paint job on that motorcycle as well. And of course, no visualization tool would be complete without looking at beautiful visuals. Things like images. Unreal is capable of producing very high-res still imagery, and you can produce massive images very simply out of Unreal. We'll take a look at how we can do that. As well, video. Here we're looking at a sample of Sequencer and how we can build something very cool, like a little cutscene or a simple little commercial, something like a very simple sequence that we can output into a video, so that we can visualize our data in a very compelling way. Another very interesting thing about Unreal Engine is this ability to extend your visual capability into immersive realities, things like virtual reality. Here we are with a Vive, exploring the motorcycle in virtual reality to scale. And that's something very cool, that we can experience the designs virtually, and perhaps before they even exist, right? To be able to look at these things and be able to experience them in different ways, to explore the design before it's even built or even physically exists, or before it even sits on a showroom floor, for example. The last thing we want to do as well is point out that, of course, with Unreal, you're getting industry-proven tools. Epic has been building this engine for a few decades now, and you really are getting a lot of amazing technology that has figured these things out. How to visualize things beautifully and effectively in a very powerful engine. What makes an effective visualization? Let's take a moment here to just go over a couple of points of what an effective visualization is. So effective visualization is something that provides a visual description of the concept or idea. It's something that's true to measurements and scale, and ideally it's something that doesn't stray too far from reality. So the idea of having an object within your tool, in this case Unreal Engine of course, we want something that is going to represent reality. We want accuracy with our data as well. We also want something to tell the design story in a very compelling manner. Ideally, when building a visualization, this idea of creating an experience is something that Unreal Engine can certainly provide. You have the ability to create images, still images. You have the ability to create compelling video. You have the ability to create a live, interactive, real-time experience. But you have the ability to expand on that with things like virtual reality or augmented reality, of course, as well. So many ways to experience the design in Unreal Engine. Let's take a look at the traditional CAD to Unreal Engine workflow here. So with CAD data, typically in the past, it's been quite a bit of work. It's quite a process to bring over to Unreal Engine. Here's a basic outline as to how this would typically work, or the workflow, or what's involved with taking CAD data and attempting to get it over to a game engine effectively. Something very time consuming as well in the past. And we're going to look at how this has changed recently with a recent announcement here with Unreal Engine as well. So we start with our CAD data, wherever that may be. Let's take the Modus motorcycle here as an example. That data is built in SolidWorks, right? So it's designed, all the data is built in SolidWorks, and then from there it's exported. So the data from whatever package CAD data would be built in would be exported into a format that is 3D content creation software friendly. So this is where we get into things like 3ds Max, Autodesk Maya, maybe Cinema 4D, whatever it is you prefer to use as your 3D content creation tool. Or maybe you don't even prefer to use those, but you need those to translate that data, right? So the idea of exporting this from one package to another, the idea of things that may be lost along the way. Of course, once we get into that 3D content creation package, a couple of things need to happen. The data needs to be cleaned up typically. Quite often CAD data and the way that surfaces might be built in an automotive workflow, for example, they don't typically come over as clean as they are in those packages. So that translation, or something lost in translation for that matter, can end up having an impact on your data. Of course, working with UVs or texture coordinates is something that is required to work within a game engine environment. So this is a bit of a different concept for the CAD world. The idea of texture coordinates is something very different quite often to CAD designers that don't have a 3D content creation package experience. And we're going to look at a little bit of that a little bit later on as well. And of course, organizing this data. Taking everything that you've done in that CAD package, perhaps it's lost, and now you have to redo this again. You have to organize or group things how they were. If they were grouped into by components or by engine section, or maybe even grouped by material, whatever it may be, you may need to reorganize that. Quite often that is the case. And then converting this data. Once again, now you're in their 3D content creation package. We've gone through all this translation, this cleaning up, adding texture coordinates with UVs, organizing it. Now we want to get it out of there. We need to convert it into something that is game engine friendly, something that can go into that game engine and actually visualize it effectively. And quite often this involves a process of tessellation, which is the translation of that data into polygons or triangles. We'll look at that a little bit later on as well, but this idea of tessellation, I use that loosely because this could also require a complete rebuild of your data, or at least a rebuild of components of the data so that they do translate into polygons or triangles effectively. So traditional CAD to Unreal Engine workflow problems, or CAD to a game engine workflow. Let's take a look at some of the problems here. And there are quite a few. I highlighted a few of them as we went through that little workflow of the traditional CAD to game engine way. It's time consuming. It's a lot of work to translate that CAD data into something that a game engine can support and visualize. So there's a lot of work to get that data to translate from one world to another. And we're seeing that that gap between the world is now closing, which is really exciting. And we're going to take a look at how that gap is really closing rapidly here with Unreal as well. This traditional CAD way of working can be very expensive. Expensive in time, because it's time consuming, but expensive as well in resources, taking in staff or even other tools to be able to do what you need to do. And it might be expensive in the way that you may not have the expertise, and you may have to hire outside somebody that knows these other packages or this other way of working in this other lingo, this other world of data that 3D content creation tools often bring with them. Of course, you may need experience in both CAD and 3D. And again, there is a difference. Those worlds there can be quite different. Sure, they have the similarities of virtual objects or three-dimensional objects working in a design application, but there is different lingo, there's different terminology. The idea of working with a surface in one package is completely different often than working in a surface in another package, for example. Things like texture coordinates that I pointed out, this is a bit of a different world between these two packages, so it can become very time consuming, and it can become quite a big project just to get that data into a game engine previously. And of course, it can become complicated. There can be quite a big learning curve, especially if you have to jump from package to package to package to give you what you need to get that data where you want it to visualize it. Let's look at some more problems associated with this. Well, there is this need to conform assets for real time, and I touched on that a little bit there. This idea of cleaning it up, adding texture coordinates, but also tessellating it, right? Getting it into something that will actually behave properly in a real-time engine for visualization. Another problem is things that are lost in translation, like materials, lights, and cameras. Sometimes it's very difficult to bring that over, or none of it comes over at all. So those things can be lost, things that are very important in that workflow. Scene hierarchies are lost. I mentioned about these things of organizing. Maybe it's organized based on components of that CAD data. Maybe it's organized by material. Whatever it is, it could be lost, and as a result, you end up losing all of that work, all of that organization, that grouping, that hierarchy, to bring it forward over to your visualization tool. References, instances, same idea. Most often they're gone. They're lost in the file translation that is necessary to bring it into a game engine for visualization. So introducing Datasmith. Now Datasmith, if you were following along with SIGGRAPH, or if you attended SIGGRAPH this past summer here, you would have heard of this big announcement from Epic with Unreal Engine called Datasmith. And Datasmith is very exciting for the world of CAD data, or for that matter, data that was typically foreign for Unreal Engine in the past, or difficult to bring over to Unreal Engine. Datasmith solves those problems. Let's take a look at what Datasmith is all about. Datasmith, I'm going to cover some basics here, and then we'll take a look at a live demo of it here. Datasmith simplifies the data migration into Unreal Engine. So we looked at the complications in that traditional CAD to game engine workflow. This sets out to solve those problems, to make it quicker, to make it easier, to make it less of a headache, to migrate that data into Unreal Engine. The other thing as well is this idea of complete scene conversion, retaining those things that are often lost in translation. Things like materials, lights, cameras, for example, things like scene hierarchies, the ability to retain that information. Auto UV generation for light maps is another feature here that is being worked around here with Datasmith, and I should point out that Datasmith is in a beta program right now, so it is a definite work in progress. It's very exciting how far the dev team has pushed this. It's some excellent progress. It's an awesome tool that solves a lot of problems right out of the gate, that's for sure. One of these things I mentioned before was this idea of working with UVs. And there are a couple issues with that. You may have someone from that CAD world that is not familiar with the idea of texture coordinate generation. They may not know what that is, or why you need that, or what's involved to get there. UVs typically can be quite a bit of a headache, especially manual UV layout. Now, Datasmith, where it exists right now, is not going to solve every UV problem. In fact, I don't know of anything that can solve any texture coordinate problem on its own. There's always manual work required. Still to this day, there's always manual work required to get hero assets to look the way they need to look for their purpose within Unreal Engine, or any game engine for that matter, or any renderer for that matter. So what Datasmith sets out to do is solve those problems. It's kind of twofold there. I don't know what UVs are, so the auto UV generation, taking care of that for them. But also this idea of you might have thousands of objects, 2, 3, 10,000 objects in that scene. It's a lot of work to put UVs on. So this idea of having auto UVs generated to bring over into to Unreal Engine, into your scene, to take care of that for you. And again, of course, hero assets that might have logos or specific liveries on them, specific details, those are going to require a little bit more of a manual overview, a manual look at, to make sure that they come over fine and texture fine. Again, I just mentioned this is an ongoing beta. Of course, Chris mentioned this at the beginning as well. It's an ongoing beta, and there's more to come. It's work in progress, and it's very exciting what's happening with it and where it's leading to. Let's take a look at where it's leading to here right now as to how Datasmith works with our Modus motorcycle. So when working with this data, we can see that the objects that came over here were actually built in SOLIDWORKS. So you can see that we have a pile of SOLIDWORKS assembly files, SOLIDWORKS part files. And once we bring all of these objects into 3ds Max, and we set our import settings, and we bring them into how we want that data brought into Max, we now have this ability to take advantage of 3ds Max to provide areas that are lost from that CAD data, or don't exist on that CAD data. And this is where we want to work with things like UVs. Now, maybe there might already be some materials or lights perhaps on this object. And that's important because we want that data to maybe carry forward into Unreal Engine. We might want the ability to add to this, or to add to the scene hierarchy, or to add to the way the data is organized. But the most important thing here is that we've brought the data over into Max, and that usually is quite a straightforward process. Max is excellent for that. We select all of our objects here, and now let's bring it over to Unreal Engine. How do we do that? You can see that we have a zillion different components for this motorcycle. How are we going to bring all these different pieces? That's typically too heavy for a real-time scene. A lot of this data is very heavy. So what we want to do now is work with exporting this, taking advantage of the Datasmith plugin. And we can simply do that with the plugin installed. And in this example, we're using Max, but Max is kind of the first guinea pig out the gate here for translating this data. There are many packages here that the goal is for Datasmith to provide this ability to export. So with that plugin selected, we would simply export our data using the Datasmith plugin. And then what we would do is bring this into Unreal Engine. Now, on import, Unreal Engine also takes advantage of this Datasmith plugin and takes a look for a specific file, an actual .u Datasmith file. And with that, we get a menu option here as to how we want the data to come over, how we want everything to translate, things like lights and cameras, textures, materials. Do we want to preserve those, or do we want to replace them with other materials that we may have set up here in Unreal? The import process is actually quite quick for the density and the size of this data here. So once we import it over into Unreal, it goes through its process of bringing it into the content browser. And this is one of the most, the biggest things here with Unreal Engine is the content browser and the way that data is handled in Unreal Engine's project-based setup. So we can see that our data has come over here into Unreal Engine. The motorcycle looks pretty much exactly as we saw here in 3ds Max. And we also have everything outlined in the outliner here. Everything is set up nicely and organized. So we've got those hierarchies, we've got those groups, and we can see all the separate components here in the content browser. All these different little pieces and components that represent the makeup of this motorcycle. So right down to the nuts and bolts, literally, of this motorcycle. You can see we have gaskets and all the different pieces, everything here of the real design of this motorcycle. And that's important because if we want to produce an effective visualization, we want to make sure that we have accuracy. We want to make sure we have reality of what the actual product is so that we can fairly and accurately represent it here with our visualization. And the great thing, of course, again, as I mentioned, is all these different groupings and hierarchies come over from translated through from CAD right through to Unreal Engine here. So I feel it necessary to take a look at some terminology. You know, I've talked a bit about this difference between the CAD world and this game engine world, or even regular different or all different 3D content creation packages. For example, Max or Maya, or whatever it may be that a CAD designer or someone from the CAD world may not be familiar with. So let's take a quick overview. Let's do a quick overview of some terminology related to these different concepts in this 3D content creation world or the game engine world. So things from CAD to get into the game engine world. Polygons and triangles. So this is where the data is tessellated to work within a real-time environment. And I mean in the sense of work, it has to perform. And when you have something that has to drive a lot of data, geometry, a lot of materials, textures, lights, there's a lot going on in a game engine to produce real-time imagery. We need something that is going to run smoothly. And polygons and triangles are the geometric solution for that tessellation. So the CAD data is translated into polygons and triangles. You know, simple enough in a lot of ways. Most packages have a way to tessellate or export polys or tris in one way. But it needs to be accurate, right? We need to have something that's going to properly represent the CAD design, the accuracy of those curves, for example. So in a game engine, that's always been a bit of a battle there, is taking that dense CAD data, dense in the sense that once it's translated to polys and tris, it can be very, very dense, very big, something that's not going to perform well in a game engine. But the trick there is to get something that tessellates nicely, is accurate to the CAD data, but performs well within the game engine. So tessellation and retopology, we touched on the idea of tessellating into polys and tris, but there's also this idea of retopology, and this is at times where there may be a bit of a cleanup or a rebuild of objects. Now, a lot of that is really becoming a lot easier. Datasmith is certainly making that easier in the way that there is a nice way to tessellate this. There are a lot of tools out there as well, like 3ds Max, that you can take advantage of to help with your CAD data workflow as well. So if you're coming from something like SolidWorks or another package and you want to take advantage of 3ds Max, 3ds Max provides more than just being a data work through or a translator. It has this ability to, of course, help with your modeling or produce UVs or help with your texturing, your materials, or lights. So there are different advantages, of course, to using a package like 3ds Max when it comes to these workflows, the additional tool set that it brings. And retopology is an area where those tool sets can come in handy to help with, you know, problem areas that may not translate well from the CAD world into the 3D world. Now, things are changing so rapidly that we're starting to see this gap close between the CAD world and the 3D content creation world. So I think we're going to see that become easier and easier as things progress, especially here with Datasmith. Texture atlasing. Well, this is something that touches upon the idea of having textures in, you may have dozens of textures or perhaps even thousands of them. That can bog down the performance of your game or your visualization within Unreal Engine. So working with a texture atlas is a way to take advantage of one sheet and place many textures on there. So this many to one idea, rather than having, say, for example, a dozen textures on all different sheets or different texture images. The idea of producing one image that fits in the power of two, and what that is this 1024 by 1024 or 2048 by 2048. It's a square resolution in the sense that we can pile these textures in as an atlas and be able to bring them in to a game engine, to Unreal Engine, to produce good performance and have good visualization. Now, of course, to get those textures, we need, again, UV coordinates. And UV coordinates are essentially the coordinates that allow for textures to be placed on those polygons or on those triangles so that they will display correctly in your renderer of choice, in this case Unreal Engine. So that once the UVs are provided on there and they're placed properly and clean, things like logos and details from different types of textures, tire details, whatever it may be on the rubber or something, for example, if it's a texture, requires a texture, UV coordinates are going to produce that accurate detail there for you. If you don't have UV coordinates, you're not going to have texture. If you don't have clean UVs, you're going to have a messy texture. So UVs are very important, especially when it comes to visualizing data with imagery as textures. Post-processing. So this is a process within Unreal Engine that is very powerful, and we're going to take a look at that in a little bit here. And that's the ability to take advantage of real-time rendering effects. So things like ambient occlusion and bloom effects and all different ways to anti-alias or perhaps to up your reflections within your scene. So many different image effects that really pop or make the scene look that much more beautiful as you work on your design. And light maps and light baking. This refers to the process of lighting your assets, your scene, and then actually baking that light into essentially texture maps so that the lighting, it doesn't need to be calculated every single time for interaction with your design. This is especially useful for something like if you're going to take your CAD design and turn it into almost a playable interactive visualization, or for something like virtual reality where performance is key. And this really helps by lowering any kind of performance hits that lighting can provide. Lighting can be very hard and very intensive on performance, especially if it's dynamic lighting with real-time shadows where the light is moving and the shadow is moving with that. So Unreal Engine takes advantage of this process called light mass, which we'll look at here momentarily, and how it works with something called Swarm, which is essentially almost like, you can think of it as a render node or like a back render farm that is going to take care of those light maps for you to render or to bake them out. All right, let's take a look at the Unreal Engine rendering process, and that is what's involved in rendering in Unreal Engine. So in Unreal Engine, there are a couple of key things that we want to follow with rendering. And nothing can be really beautifully realized without the importance of utilizing materials. Unreal Engine has an amazing assortment of materials, but on top of that, an incredibly powerful material editor. And what we can find here within Unreal Engine is this ability to create infinite materials. And this is one of Unreal Engine's key big performance, a real beautiful feature that Unreal Engine has is this ability to create amazing materials. And I want to point out in this example here, I'm changing materials here on the Modus motorcycle, and I'm applying this different kind of paint to this here so that we can take a look at different kind of paint effects here on the different paint materials, for example. You can see that there are different ways to apply these materials in Unreal. Dragging and dropping them directly on an object, or even selecting the object and having it driven, or the material driven to the object, as well as dragging and dropping the material right on the material node of the object in its details panel. So a couple of different ways to work with things in the viewport here as well in Unreal Engine. But the beautiful thing about these materials is that they actually come from, these are automotive materials that were built and are actually available free for use from the fine folks at Epic Games. And this is available actually right within your Epic launcher. If you go into the launcher and go into the marketplace and then just drive into the categories, if you actually take a look at the materials under the categories, and the quickest way would be to type into the search bar up in the top right corner, just type in automotive. And by setting up a simple little search there, you'll see automotive materials. Now this is free for you to use, and you can grab these materials and play with them They're beautiful materials for, especially for anything automotive, or for in this case here as well, this motorcycle. But they're also excellent resources to see how these materials are built with the Unreal Engine Material Editor. So there's all sorts of different materials. I would definitely advise you go in and take a look at them if you haven't. Play around with them. Some beautiful materials for visualizations in there. So another thing here with the placement of materials, we talked briefly about this idea of utilizing the material editor here in Unreal. Well, what we can do very easily and very quickly in Unreal Engine is create something called a material instance. And what that allows you to do is create essentially something like a copy of a material, but it's a live copy in the sense that it doesn't affect the original, but there are attributes promoted from that original that you can affect. So in this case here, changing the color, for example, on our engine component here, I can go in and change this to whatever color I want, and very quickly, so that I can take a look at these different iterations of design, or this different overall look or feel that I may want to explore with my design, or I may want to apply that fits in a real world paint scheme or color scheme of this design. So there's just a quick way that you can play with different materials, and material instancing in Unreal is very powerful for that. The idea of creating one hero material and then several little instances of it that have the ability to change things on the fly very easily as well. And then of course, with materials here, these automotive materials have a beautiful array or assortment of metals. And some of them are these really nice chrome materials with beautiful reflections, and of course some alloys as well. So you can see this gold kind of alloy we're putting on here. And then very bright, very clean, very shiny chromes. I'm using something that's kind of more referred to as more of a dirty chrome, something that's maybe a little bit buffed here on these pipes. And you can see that if I can drag and drop, or I can grab a bunch of them at the same time and just drive that material directly onto multiple objects all at once. Very quick way to work with materials there as well. Another thing, we looked at the importance of materials. Let's take a quick look at the importance of lighting in Unreal Engine. And this is the ability to add lights to the scene. It's very easy in Unreal. There are 4 key lights: directional, point, spot, and a skylight within Unreal Engine. Let's take a look at a simple spotlight here. So a spotlight's a very basic light. I'm just hitting G here in the viewport, so I'm displaying all the different icons on everything in here so I can see it. So if I bring the spotlight into the scene, one of the things I'm going to notice here is it's actually quite small, and it's not incredibly powerful, so I might want to turn up the intensity on this to get something as well. I also want to expand the cone and the attenuation on this so that it's actually lighting a greater area than what the default cone size brings to it as well. But with a spotlight, what you're going to get is essentially light that's projected within that cone. So it specifically is within that cone, and you have the ability to translate that and of course rotate that around and scale the overall size of the cone. And of course, like any light, you have the ability to work with the intensity there of it as well. So with a spotlight, it's a very simple light. For something like this visualization here, of course the ability to change colors on any light is nice for the visualization, but one of the lights that we really want to take a look at here is a directional light. And that's what I'm using in this scene for these visualizations here, is I'm simply taking a directional light, I'm getting some beautiful lighting on here, and I'm able to rapidly on the fly change it. A directional light works in the sense that it's only by rotation. Translation isn't going to affect it. Think of it as the sun. It's an infinite source essentially that is light coming directly down towards your object here, and you're able to work with that live in the viewport. Now the shadows can be a big performance hit. So this is where we can adjust the overall shadow resolution to be, or shadows, how they work, if they're dynamic, that is movable, or if they're static. And static is much easier on performance overall within our scene. So when working with lights in Unreal Engine there, that is something that we want to take advantage of, is keeping in mind what we're doing with the scene. If we're going to be using this in an interactive sense, building this into a playable interaction, or for virtual reality, or even for using something in like the sequencer there, you want your performance to work. And if the performance is taking a hit from the lighting, you're going to see that impact your overall project as well. So let's take a look at world settings and light maps. Now, world settings is the area within Unreal Engine that allows you to tweak the overall setting or appearance of your data. So here with world settings, for example, I'm just clicking on settings and world settings. You'll see a tab appear next to the details panel. This is where we have all the settings for our rendering. Now, I'm not going to dive into all of them here because there are quite a few things to look at. But some of the basics that we definitely want to look at here are up near the top. So some of these different little settings in here, like our static lighting and how number of indirect lighting bounces, for example, all of these things will have an impact on the quality of your lighting. But as well, anytime you're impacting quality, especially if you're pushing the quality up, you're going to impact the overall performance. So you want to be careful with these settings. Pushing it too high can have a very negative effect on things here as well. So we want to be careful with how we affect or how we adjust our settings as we work with them. I should point out here as well that everything in Unreal, typically anything that's an attribute or a parameter, will have, if you change it, will give you these little yellow kind of squiggly arrows. And if you click them, that just essentially resets back to its default parameter. So it serves two purposes, to reset it back, but to also indicate that a change has happened in that place as well. So there's a quick look at the overall world settings there. Let's take a look at what happens with lights when they're baked out in Unreal and what we do with those lights or those images that are baked out, for example. This is where we create something that is referred to as light maps. So light maps can be found through the world settings in here. So if we go underneath our lighting setting and we just want to expand our menu out, and we'll see light maps, and we can see that in this scene I have 198 light maps that I'm actually working with in here. For the final sequencer, I actually rendered or baked the lighting out at a high level, and you can see all of these different light maps. They look very strange, some strange coloring going on. And if we double click them, we can see that this is just data stored on an image that we're able to see and utilize within our scene. So I can see the size of this texture, 1024 by 1024, and it essentially works like a texture map that allows me to place within our scene here as well. Let's take a look at light mass and how that works with Unreal Engine. So light mass is Unreal Engine's light baking here. So you can see I've set this to high. It's advisable you start with preview and work your way up because this can be very intensive on the performance, but also it can take a long time to bake your lighting out. But here's an overview of what happens. Once we bake our lights, you're going to see that it's exporting the lighting data, but there's also something that's happening down in the bottom corner of your screen. And you'll see a little swarm icon, and this is where we get what is referred to as a swarm agent. And it's going to load in all the data. So it shows the process, exporting the scene, light mass is starting, how it's emitting the photons, how it's collecting those photons. It goes through an entire process. And the closest thing to liken this to would be like rendering. Essentially, it is basically a render node that is rendering in the background all of these different lights as to how they work within the scene. And then we can take those light maps and apply them very easily to our overall visualization as well. Let's take a look at post-processing in Unreal Engine and how that works with visualization. So post-processing and image effects in Unreal Engine are actually really nice. So if we simply come over to volumes here, I'm going to grab a post-process volume. I'm going to drag it over our Modus motorcycle here. I'm just going to scale up that box. So you can see I'm just using the simple scale, and I just scale the size of this. And then hitting my W hotkey, I'm translating it around. I'm essentially going to envelope this motorcycle is what I want. I want this motorcycle encapsulated by that box, that volume, so that we have it ready to go. And then once it's encapsulating that, this allows me to define to Unreal that this is the only area I really want to work with these post-processing settings. So I'm telling Unreal, this is the main hero area, the motorcycle. I don't really care about applying these post-process effects outside of my main CAD data here. I want to apply these post-process effects just within that box volume that I've built there. So let's take a look at a couple settings here. And I've got a couple that I've already played with in here for this visualization. But some of the interesting settings that we can work with that post-process volume brings with it to provide a really beautiful image is the ability to take advantage of things like global illumination, for example, and of course ambient occlusion. And ambient occlusion really gives that kind of filling in those voids, and it really gives that nice subtle shadowy effect live within the viewport of your scene as well. And of course we can adjust these things real time. We can adjust the intensity or the radius of them as we work with them as well. So post-processing in Unreal Engine allows you to apply these different image effects within the viewport, all sorts of different image effects. You saw we worked with reflections. We can work with things like screen space reflections, and we can see the difference that these type of reflections apply within the scene. I should point out that anything within post-processing really makes your image look beautiful, but it can be costly on performance. A lot of these effects here are beautiful for visualizations like imagery and for sequencer, but they're not yet right there for things like virtual reality. They can take a hit on performance for things like virtual reality, where every bit of performance is absolute key when it comes to virtual or augmented reality there as well. And we can work with things like blooms. You can see I got these nice bloom effect happening off of this shiny chrome. So that's a quick overview of how post-processing effects work in Unreal Engine. Let's take a look at Unreal Engine visuals and how we can create some beautiful visuals here finally out of Unreal Engine. So we have a couple ways that we can do that. Of course, here we have the ability to real-time interact with our data, which we're simply doing here. We can tumble around and view the data and see how beautiful it is. And of course, we also have this ability to work with components. So we can highlight components as needed. We can pull components out if we needed to out of the engine, out of this bike. But we have this ability to interact with real time. So this experience of the design, real time in the viewport, or building that out as an interactive application as well, so that a design can be experienced as an interactive, almost like a gameplay as well. I want to take a look at how we can build a simple sequence. So using Sequencer underneath the Cinematics tab in Unreal Engine produces beautiful visuals. So this is a way that we can create a nice little cinematic or a simple little visual experience here that we can output as a video. I should point out Sequencer is much more than that. It's not simply just a visual image tool. You can actually work with things like animation in there, models, for example, different pieces of geometry that are doing specific things, materials, lighting. It really is endless. It is like a film editor that is infinite in the sense that it can work with more than just imagery. It can work directly with objects, lighting, effects, materials, and it allows you to create these very cool visuals on the fly. So this is just a really quick way to work with cameras. Here I'm just simply taking some cameras in Unreal Engine, and I'm simply creating this little cinematic or this little cutscene here for my visual to really visualize this design or this CAD data here in Unreal Engine. So I'm just working with cameras in different ways, sailing them across the motorbike or around the motorcycle here as well. Something that will really show off the beauty of the design of this data here. Once we have all our different cameras, then of course I can work with this in the sense of much like a film editor. I can stack them together, I can put fades in between them, and then I can render this out. So here you can see I'm rendering out simply a little video sequence. I'm going to render this out at 1080p for this example. Keep the quality pushed up there as well. And then we just simply go ahead and capture movie, and that's going to write a movie into my Unreal project into a place that's actually under saved. You'll see a video capture area there right near your directory where your images, your screen images that you render out will go as well. And we can produce that simple little visual, and we end up with this simple little cutscene here. So I'm just going to scrub through it. And we can get different kind of nice ways to kind of showcase the overall design here. Taking advantage of the materials, taking advantage of the lighting, taking advantage of cameras, some post-processing effects as well, and just a nice way to showcase the overall design from the great team over there at Motus that provided us with this data. So this beautiful motorcycle here, and how we can visualize this real time in Unreal Engine. So we looked at how we can work with that real time, how we can work with this with Sequencer. Let's take a look at how we can work with still images in Unreal Engine. So Unreal Engine has the ability to produce some very compelling still imagery. So here I've set up some simple bookmarks, and you can go up to the little pull down menu on the top left of your viewport and simply set by the number keys bookmarks. And you can access these. I've set up 4, so I can just hit 1, 2, 3, 4 to jump to those. And then if you go to the high resolution screenshot window, this is where you can essentially multiply up the size of the image. So if you have a big resolution display already, you have a card that's capable of doing this, you can get a nice big image, but you can multiply the size of that and produce massive images. Huge images up to, really, the resolution is up to your hardware configuration. But it produces beautiful imagery here that we can work with quite simply as a nice visualizer here. And one last area that I wanted to take a look at is the ability to expand this visualization outside of just still imagery or video imagery or interactive play, but something very cool here, but using virtual reality for your overall design. So a couple of things that we can take a look at here with, while we're looking at this. This is using the Vive live in Unreal Engine. And what we can also do is, examine ways that virtual reality really plays a part in the design workflow here. So some of the things that we have, so we have this ability to take advantage of experience versus viewing. This idea where the viewer is in control. This allows for unique experiences per viewer, so the viewer can have their own unique experience. And this ability to have a guided tour or something that's fully immersive for design, for the ability to walk around a design. So VR and visualization, just very quickly, it's an extension of the visualization toolkit. You can take advantage of real-time, in-data visualization. And this ability to have visualization of data, for example, CAD data, this motorcycle, in an immersive experience, as well as being able to produce a remote experience, someone far away across the globe, for example. Lastly, I want to just mention some things about virtual reality and design. In Unreal Engine, the ability to take a design and actually use virtual reality for this proof of concept, this idea of walking around your data to scale in real time, where you can test in context things like materials, lighting scenarios, and also take a look at different object placement considerations, how different objects fit within that design. For example, we looked at those saddlebags as accessories. And then, of course, finding issues with the design, the quality overall. What you see is what you get in virtual reality. It's pretty difficult to hide things. So if something's not working with the design or a material or light, you're going to find it. You're going to see it in virtual reality. So I want to thank you for joining me today for this webinar on the ability to use Unreal Engine for visualizing CAD data, for visualizing product design. I hope you enjoyed it. Thank you for attending.